Welcome to my YouTube channel Btechnical. So we have started a revision lecture series for geotechnical engineering. I have already uploaded 2 lectures, lecture 1 and 2, which is available on my channel. So this is in continuation of that lecture. Let us start. In previous lecture we have discussed so many relations based on that the numerical question may ask in the exam. So in lecture 2 we have discussed already about liquidity index. So there is some range of liquidity index. So if liquidity index is, that is IL, if IL is less than 1, it is brittle solid. Brittle solid. And if it is greater than 1, then it is called as viscous fluid. Viscous fluid. And if it is 0 to less than IL is less than 1, between 1 and 0 and 1, then it is called as plastic state. Okay, so liquidity index, if less than 1, it is brittle, and if it is greater than 1, it is viscous fluid, and if it is in between 0 to 1, then it is in plastic state. There is one more index, that is toughness index. This is the ratio of plasticity index to flow index. This is designated as TP, toughness, that is plasticity index to flow index. And the range for this is 0 is less than IT, toughness index, you can say IT, not TP, this is IT, toughness index. So 0 to 3, if it is in this range 0 to 3, then it is a means you can say the it is in good condition. So most of the soil is between 0 to 3. Most of the soil, the toughness index of most of the soil is between 0 to 3. If it is, if the toughness index is less than 1, then the soil is friable, that is easily crushed. Easily crushed. There is one more index, that is called consistency index. So consistency index plus liquidity index is always equal to 1, because both are the ratio, and denominator of both index is plasticity index. So when you add together, it will come to 1. Now come to soil classification. Soil classification. So soil is classified in coarse grained soil and fine grained soil. In coarse grained soil, it is in 2 types, that is, one is called gravel and other is called sand, that is based on the size of the soil. And in fine grained also there is 2 types, one is silt, other is clay. So which soil is called as gravel? Gravel, when you did the sieve analysis, the particle size is retained on 4.75 mm, means the size of soil which is greater than 4.75 mm is called as gravel, and between 4.75 mm to 75 micron is called as sand. So if the soil is retained on 75 micron sieve, it is called as sand. And when it is passes from 75 micron and retain on 2 micron, then it is called as silt. And less than 2 micron is called as clay. This is the soil classification system. Under fine soil, there is a sedimentation analysis. And one relation which is given by Stokes, also called Stokes law, which is applicable for sedimentation analysis. So one relation in which you can find out the settling velocity, Vs is equal to g minus 1 into rho g d square, divided by 18 mu, and we know the mu is the viscosity and nu is the kinematic viscosity, that is the ratio of mu upon rho. So you can also write 1 by 18 nu g minus 1, and rho mu by rho is cancelled out, so g into d square. This is the expression for Vs. One numerical question also asked on this relation. Now coarse soil further classified as well graded soil and poorly graded soil, then well graded sand, poorly graded sand, like that. So there is a symbol which used for this classification system, like GW. GW is the well graded gravel. Like that, GP is poorly graded. Which one is? This one is poorly graded gravel. Similarly, GM, if you see here, G is for gravel and W is for well. G is for gravel, P is for poorly. Again, G is for gravel and M is for silt. So this GM soil is called as silty gravel. So similarly for other, GC is clay gravel, SW is well graded sand. Here S is for sand and W is for well graded, like gravel, and SP is poorly graded sand, SM, M for silty, S for sand, so silty sand. Again S for sand and C for clay, so clayey sand. Okay, so these are the classification which may ask in the exam for coarse grain. Similarly for fine grain soil, it is classified based on the liquid limit. Okay, there is a curve. Okay, here is a line, this is called A line, and the equation of A line is equal to IP minus 0.73 into WL minus 20. So here is the liquid limit. Okay, means 35% liquid limit, 50% liquid limit, and greater than 50% liquid limit. Means 20%, 35% or 50%, like that. And these are the A line. So fine grained soil is classified based on this liquid limit. So it is 3 category. When liquid limit, that is WL, is less than 35%. When WL is less than 35%, in that case three symbols are used, that is Cl, Ml, OL. Cl is the inorganic clay with low compressibility. Inorganic clay with low compressibility. Ml is the inorganic silt. Here M is for silt. Inorganic silt for with low compressibility, and OL is the organic silt with low compressibility. So O for organic, C for clay, M for silt, and L represent the low compressibility. Second case, when liquid limit, that is WL, is between 35% to 50%. In this case also three symbols are used, that is Ci, Mi, Oi. So it is also same as above manner, that is Ci, here C is for clay, M is for silt, O is for organic clay. So Ci is the inorganic clay of medium compressibility, Mi is inorganic clay of medium compressibility, and Oi is the organic clay of medium compressibility. And third one, when liquid limit is greater than 50%. When liquid limit is greater than 50%. In this case also three symbols are used, that is Ch, Mh, OH. Again here C for clay, M for silt, O for organic. So this is clay of high compressibility, silt of high compressibility, and organic clay of high compressibility. One numerical question sometimes asked on the group index. Group index, also called as GI in short. So the empirical formula for this is 0.2 A plus 0.01 BD plus 0.005 AC. We can write this is first for remembering purpose. So 0.2 A plus 0.005 AC plus 0.01 BD. So A, AC, BD. This is just for remembered person. A, AC, BD. So this is the formula for group index, where A is the P minus 35, which is not greater than 40. B is P minus 15, which is not greater than 40, where P is the percentage finer than 75 micron. And C is the WL minus 40, where WL is the liquid limit, it is also not greater than 20. And D is the plasticity index minus 10, which is also not greater than 20. So these are the range of A, B, C, D. From this value we can find the A, B, C, D and put in this formula, we will get the group index value. So once you obtain the group index value, then you can decide the what will be the quality of subgrade. So here is the range. If group index is lie between 0 to 1, then it is called as good subgrade, quality of subgrade is good. And if it is between 2 to 4, then it is fair. Between 5 to 9 it is poor, and it is if it is between 10 to 20, then it is very very poor subgrade quality. Okay, so keep the value for good quality of subgrade, the GI value should be 0 to 1. Now let us talk about clay minerals. I have already mentioned in previous one, that clay mineral, there is 3 clay minerals. One is called as kaolinite, other is called as illite and montmorillonite. So kaolinite is strongest, having hydrogen bond, and illite is ionic bond, and montmorillonite is a weakest bond, that is water bond. So maximum or highest swelling may occur in montmorillonite clay minerals, highest swelling and shrinkage property. Illite has medium swelling and shrinkage property, and kaolinite has no swelling and shrinkage property, so strongest. Now let us write the expression for seepage velocity. Seepage velocity. Seepage velocity, that is Vs, is equal to V upon N, where V is the discharge velocity, N is the porosity. So this is equal to V upon N. Similarly, the seepage discharge, that is Q, can be obtained. Q is equal to K into I into A, where K is the permeability, I is the hydraulic gradient, that is I is equal to del H upon L, and A is the area of percolation. There is one term, that is percolation coefficient. Percolation coefficient, that is Kp. Kp is equal to K upon N. K is the permeability, coefficient of permeability, N is the porosity. N is the porosity. So K upon N, this ratio is called as percolation coefficient. There is so many empirical formula to find the coefficient of permeability. One is called as Kozeny-Kármán equation, in which this relationship may directly ask in the exam. K is equal to 1 by Kk into gamma W by mu into E cube divided by 1 plus E into D square. So K is directly related to the dia void ratio and unit weight, then inversely proportional to viscosity. Similarly, the other relation is same one, only difference is that here it is related to the shape. Here it is related to the dia, here is related to the shape. Next one is the Allen-Hazen equation, in which K is directly proportional to the square of the effective size of the soil. So K is equal to 100, here 100 is the coefficient. In generally we use K is equal to C D10 square. So C is the value for Allen-Hazen equation is 100. Now next one is consolidation equation. So here the permeability K is equal to Cv, Mv and gamma W. Cv is coefficient of volume, coefficient of consolidation. Mv is the coefficient of volume compressibility, and gamma W is the unit weight of water. Next one is Terzaghi's equation, in which K is equal to 200 E square into dE square. So these empirical relation from which you can find out the permeability coefficient, and there is also a relationship developed with the coefficient of permeability to another things. So from this empirical relation you can find that K is directly proportional to square of this diameter, inversely proportional to square of shape factor, K is directly proportional to temperature, K is inversely proportional to entrapped gases, K is inversely proportional to foreign impurities. As we already discussed, K equivalent in case of two dimensional is Kx into Ky to the power 1 by 2, that is root under Kx into Ky. Similarly, in three direction, K equivalent is equal to Kx into Ky into Kz raised to 1 by 3, or cubic root, you can say cubic root of kx, ky and kz. There is another relation in case of non-homogeneous medium, means when flow through non-homogeneous medium, in that case k1 by k2, if it is in different angle, then this ratio k1 for one layer, k1 permeability of 1 and permeability of 2, the ratio of these two will be equal to tan theta 1 divided by tan theta 2. From this relation, if 3 unknowns are there, then you can easily find the fourth one. Next is seepage pressure. Seepage pressure PS is equal to IZ gamma W. IZ gamma W. It is in Newton per mm square. You can also write the stress sigma by is equal to gamma dash Z plus minus this seepage pressure. There is a Laplace equation. The relationship for Laplace equation in this case is del square H divided by del x square plus del square H divided by del y square is equal to 0. This is the case when the material is isotropic equation, you can say, isotropic medium. So for isotropic medium, del square H divided by del x square plus del square H divided by del y square is equal to 0. And for non-isotropic medium, this equation becomes kx into del square H divided by del x square plus ky into del square H divided by del y square is equal to 0. This question directly asks, this relationship also directly asked in the objective exam. There is some experimental method of determination of coefficient of permeability. One is called as constant head permeability method or test, constant head permeability test. This is used for coarse grained soil, and the formula for this constant head permeability is Q is equal to K into I into A. K is the coefficient of permeability, I is hydraulic gradient, A is the area. So I is, you can write I is equal to H by L. So it becomes Q is equal to K H A divided by L. And you can also write Q is equal to V divided by T and K H into A divided by L. So V is equal to T times K, H by L is again I or A. So sometimes this relation also asked. So this is depend which parameter given in the questions. If volume is given, then you have to use this expression, and if discharge is given, then you have to use this equation. Now second is falling head permeability test. This is used for fine grained soil, and the formula for this is K is equal to 2.303 AL log base 10 H1 by H2 divided by A into T. Now if you find to the vertical stress below a point load, So there is two expression by different theory. One is given by Boskin's theory, which is given by the Boskin's. In that, suppose this is the point load, and you want to find at a depth z below the surface. Here you want to find the stress generated below this point load P. If this depth z is given, then the expression is sigma z is equal to kb into q divided by z square. Q is the point load. Okay, so here kb is Boskin's coefficient, and the expression for kb is 3 by 2 pi multiplied by 1 divided by 1 plus r by z का whole square whole divided by 5 by 2 whole raised to 5 by 2. I again repeat this expression. Kb is equal to 3 by 2 pi into 1 by 1 plus r by z का whole square and whole raised to 5 by 2. If this terms are not given, like r is not given, then you can directly calculate this sigma z is equal to 0.4775 q by z square. By this equation. Okay. Another theory is Westergaard theory, in which sigma z is equal to kw into q by z square. Again here kw is the coefficient of Westergaard coefficient. Okay, and the expression for this is 1 by pi multiplied by 1 divided by 1 plus 2 r by z whole square and whole raised to 3 by 2. Whole raised to 3 by 2. So when the stress due to Boskin's theory is equal to stress at a depth z, stress at a depth z due to Boskin's is equal to stress at a depth z due to Westergaard is equal, then r by z value must be equal to 1.52. So this values asked many times in objective exam. Now we discuss about Newmark influence chart. There is another method, that is Newmark's influence chart. This is also based on Boskin's equation. This chart is used to compute vertical, horizontal and shear stress due to uniformly distributed load over an area of any shape or geometry, below any point that lies either below or outside of the loaded area. So these are the Newmark's chart. Newmark's chart, in which there is a concentric circle and radial lines. So this chart is composed of many concentric circles and radial line. So you have to read how much is the concentric circles and how much is the radial lines lie within this area, so that you can find the influence factor, and that is called as Newmark influence factor. So Newmark's influence factor. Newmark's influence factor, IF, you can say IF, and IF is equal to 1 upon m into n. This factor is called as Newmark's influence factor. Here m is the number of concentric circle and n is the radial lines. And from this expression you can find the stresses below the point. So we'll stop here. We'll see you in next lecture, that is revision lecture 4. Okay.